In this video, we will do an expected value example involving the sum of two dice. So the question says that you roll a 5-sided die and a 6-sided die. What is the expected value of the sum of the two rolls? So I'm going to begin by introducing some random variables. I'm going to let x be the number rolled in the 5-sided die, and I'm going to let y be the number rolled in the 6-sided die. So we're going to introduce two random variables here, one for each of these dies. So what the question wants is the expected value of the sum of the two rolls. In other words, the expected value of x plus y. So that's going to bring us to a key theorem about expected values. So I'm just going to state what the theorem says, and we're going to go ahead and use it. We're not going to prove this. So this theorem, I'm going to state three parts to this. The first says that the expected value of two random variables added together is equal to the expected value of the first random variable plus the expected value of the second random variable. It turns out that if you have the expected value of some number a times x plus some number b times y, that will be equal to a times the expected value of x plus b times the expected value of y. And in this equation where a and b are just real numbers. And then similar to the first one, if we have the expected value and then the sum of a bunch of random variables, this will be equal to the expected value of the first one plus the expected value of the second one, x2, plus dot dot dot, plus until the expected value of the last one, x sub k. Okay, so that said, if I can find the expected value of x and the expected value of y to get the expected value of the sum, I will just have to add those two expected values together using this first part of the theorem. So I'm going to find the expected value of y first. They're really similar, x and y. I'm going to do y first though. So for y, when I roll a 6-sided die, we can roll a 1, 2, 3, 4, a 5, or a 6, each with a probability of 1/6. So to find the expected value, I need to know each of the values of my variable. So I can roll any number, any integer from 1 to 6. And I need to know the probability of each of those values occurring. So now I can form, implication arrow, I can form my expected value of y. I'm going to take my first value of the variable, which is 1, multiply that by its probability, 1/6, plus, now the next value, which is 2, times its probability, which again is 1/6. And if I keep going like this, I'll get plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. Alrighty, so now when we put these together, whatever number is in front, multiplying my fraction, that is only going to multiply the numerator. Recall, if I do something like 3 times 1/6, I can rewrite the 3 as 3 over 1. So 3 over 1 times 1 over 6. And now I multiply the numerators together, 3 times 1. And I multiply the denominators together, 1 times 6. So if I do that sort of thing, the denominator of every single one of these fractions is going to be 6. So I can add them all together. The whole denominator will be 6. And on the numerator, I will first have 1 times 1, which is 1. 2 times 1, which is 2. Plus 3 times 1, which is 3. And then plus 4, plus 5, plus 6. So adding those together, we get 21 on the top, 6 on the bottom. And if I write this as a decimal, this is 3.5. So that is the expected value of y. So next, we can find the expected value of x. So this is when I roll a 5-sided die. So this one, I'm going to ask you to try. So pause the video for 3 minutes and work out the expected value of x, the 5-sided die. 4, 3, 2, 1, pause it, and try this one for 3 minutes. I'm actually not going to work this out in the video, so I'm going to trust that you're trying it. It's super similar to the expected value of y. Alrighty, so hopefully you tried that for about 3 minutes. As I mentioned, this time I am going to be skipping the details. I'm going to skip the computation. Instead, just write ... and say what the final answer is. So the expected value of x ends up being, turns out, 3. So thus, how we can put this together, and the question wanted the expected value of x plus y, and using our theorem, I'm just going to write THM to abbreviate theorem, this is equal to the expected value of x plus the expected value of y. The expected value of x we now know is 3. Let's highlight that. In fact, expected value of x is 3. 3. The expected value of y we had worked out, which was 3.5. Let's highlight that here. And I'm about to write it here. So plus 3.5, and if we add 3 to 3.5, we get 6.5. And that is my expected value overall for the sum. So the key idea that I want to mention, just to end this video and reiterate, is that this formula for the expected value of a sum of random variables can really help make the computation easier. Because often it's easier to just find the expected value of one random variable on its own. So this can help get us the expected value of the sum very quickly.